Okay, so we're going to go over 11 through 12 of our SIN 402 packet. So, remember, the first thing we're going to do is read the question. Okay? And we're going to circle where to look. We are going to circle key terms and then look back at passage. So most of our work comes from the question. So, in experiment 2, scientists measured. So, what did they measure here? I need to know what they were looking for. Scientists collected the root samples of young spruce and beech trees grown. They were incubated. Man, I cannot talk today. In nutrient solutions identical to those in experiment 1. So, the solutions were analyzed to determine the net uptake of NO3- and NH4+. So, and then also here. So this is your axes, right? X will be what you did. And Y will be what you measured on your graph. So here, what we did was change the temperature, and we measured NO3 and measured NH4. So now I'm going to go back here, NO3 and NH4+. So the answer to that one is A. It doesn't say, even though this N stands for nitrogen, it doesn't say nitrogen in the passage. So these are not in the passage or the graph. None of these things. They don't tell us the mass, and they don't tell us the age and the length. None of those are in the graph, so that's not what they analyzed for. So also, the thing that we matched here, it said measured in the question, but then it said analyzed in the passage. So look back at the passage to match both key terms and synonyms. So look back for the things that mean the same thing. All right, number 12. Based on figures 2 and 3, what were the independent variables in experiment 2? So the independent variable in experiment 2, that's this, and then experiment 2. That's where we go. So circle where to look. So my step 2 is right there. My KT is independent variable. For this one, what you need to know is on the graph, the horizontal one is your independent variable. It's your x-axis. So now let's go back to experiment 2. What's on our x-axis? And that's something you just need to know. Always, always, always. Dependent is y. Independent is x. Always. So, temperature and tree type. Temperature and partial pressure of CO2. So we have the temperature one. So it's between A and B. So now let's look back. What else is on our x-axis? So now we'll also look in our key, because that can also tell you. Because those are going to be two different things. So spruce and beech trees. So is that tree type or is that CO2? I don't see CO2 anywhere in this passage, so the answer to 12 is A. All right, last 3 questions. Remember, go to the question first. What was the purpose? So why did scientists use ionizing radiation in experiment 1? So where do I look? I look in experiment 1. And what do I look for? I look for ionizing radiation. So, if I'm going to go to experiment 1 here, why did we use ionizing radiation? And then I'm going to read the blurb here. So, the elementary setup here, they sprayed ionizing radiation, found my key term, gave each droplet an electric charge. So now let's see if we can find that in the passage. Ionizing radiation gives the droplets an electric charge. This one matches exactly, so we should be getting 13 totally correct. All right, for 14, the scientists determined the weight of the oil droplets so that they could. So, why did the scientists determine the weight of the oil droplets? Okay, so I know that weight, right, is going to be one of my key terms of the oil droplets. Now let's see what we were actually trying to do in this passage. Sprayed oil droplets of a known density. Some droplets fell through, generated a voltage between the two plates. So we wanted to know the weight here, because what? All right, at which point is weight was equal to F. So that means the weight was equal to the force. So I need to find everywhere it says the force on these oil droplets and then see where I can go. Calculate the masses of the oil droplets? No, because we already had that. Measure the intensity of ionizing radiation? No. For that one. Nope. Determine how much, because these don't say anything. So force and weight, they don't say anything about mass or IR. And plus, those are different things in the table. So if we look here, how the mass is separate in the table, that gives us that clue there. So, determine how much voltage to apply to suspend the oil droplets in midair. Does that help us? So the voltage between the two plates exerted an upward force. They adjusted the voltage until the droplet was suspended in midair, at which point its weight maybe, we'll say maybe on that one. And then calculate the charge carried by each oil droplet. So let's see our options here. Using this formula, the scientists calculated the charge on each droplet. So our weight force thing is what we use to calculate. Now the reason why this one is tricky, okay? So it's telling us that it exerted force. So the scientist used force until this voltage made that equation right. So it used it until this equation was true. But then, what did we do here? So, if we flip back to this question, oh man, I did the same in the same color. Determine, why did we do this? What did we want to do? And then look at here. Do you see how it says calculate, calculate, and then calculate? So calculate is actually one of our key terms. So calculate is a key term. So that means I know that it's between these two that say calculate, and then this is an exact quote in the passage. So matching it to the passage. And I'm going to remember to switch my colors for the last problem, number 15. Based on the information in the passage, the oil droplets were given an electric charge so that. So, now, let's go through. Now, there's a little, a trick here where it says based on the figure or the information in the passage doesn't normally mean the whole thing. So usually when it says passage, it means the blurb at the beginning. This is usually true, so let's find out if it's true here. So I'm going to go here. So, inside the chamber, an ionizing radiation gave each droplet an electric charge. Some fell through an opening at the bottom, and these metal plates were connected to an electric generator, which generated a voltage between the two plates. Then, elementary charge is an electric charge carried by a single proton. They wanted to measure the elementary charge. So, Let's see if that information gives us, and then we'll see there. The scientists were able to measure the masses of the droplets. Nope, they could do that anyway. The droplets were unable to leave the containment chamber. It doesn't say anything about that because it does say they fell through in the passage, so we can disagree with that one. The droplets were able to fall in the small opening. That's a maybe. And the droplets were affected by the voltage between the two plates. So, which one of these two answers relates back to electricity? So, if electric charge or electricity, whichever one you want to say, okay, what of these two actions relates to electricity more? Falling or voltage? One talks about falling, one talks about voltage. Voltage is going to be the one that has to deal with electricity, so the answer to 15 is D. Congrats.